Now we will see some practical applications of the heating effect of electric current. Now every time in every equipment or electrical circuits, heating is not desired. In some equipments, heating is desired. For example, iron, the heating rods for the heating of the water, ovens, electric oven, electric kettle, electric toaster. Now these work because they get heated. So here the heating property or the heating effect of the electric current is desired. But there are many other equipments where we do not desire it, because if it gets heated, then they get damaged. Now let us see where we are using this particular effect. Now the first one is the bulb. The bulb has got a filament inside, and when current is passed, this filament is made up of a material which is highly resistive. It has got a very high resistance, and so what it is going to do, it is going to resist the flow of current, and in this process it gets heated too much. And the melting point of that metal of the filament is also kept very high. They take a metal which has got a very high melting point. Okay, so what happens, it is fighting the electrons, the resistance is too much heat is getting generated, but the filament will not get damaged, it will not burn, it will not melt, because it has got a high melting point. But then what will happen, it will start glowing red in color, and when it starts glowing, that is the light what we get. Now this filament has to be very well insulated. Why? Because the heat should not be lost out. Otherwise what will happen, the filament will get heated, and the air which is outside the filament, that will get heated, then the glass of the bulb will get heated, that will also crack. Okay, so this filament is always insulated, and that is why these bulbs are filled up with inactive nitrogen and argon gases, so that they do not pass on the temperature of the heating filament to the outside environment, so that the bulb doesn't get damaged. And this heat which is generated when this filament metal starts glowing, this is radiated as the light what we get from the bulbs. Next application of the heating effect is a fuse. You all know that in every household there is a fuse. Now here I have just shown a very simple diagram. See that you can see supply is written. So the current electricity is coming to your house from this main supply board. It is first sent to the fuse. And you can see the one which is in cream color, it is the cartridge of the fuse. And then you can see a brown color, that is the fuse wire. Okay. So the current comes through this supply line which is shown in pink. Then it goes through this brown color wire, that is the fuse wire, and then it goes to your house implements, whatever you are, into your house circuit, like this. So via the fuse wire the current comes into your house. Now these fuses are having ratings 1A, 5A and all. So 1A is 1 ampere, 5A is 5 ampere. Suppose you put a 5 ampere fuse over here. So whenever the current crosses this limit of 5 ampere, your fuse wire is going to get heated and it will melt. Now here the fuse wire material is chosen such that it will melt the moment the current becomes greater than 5 ampere. So when the fuse wire melts, the electricity to your house is stopped, because now it becomes an open circuit, it is not closed. There is no connection from the supply. The connection was through the fuse, and the fuse wire is not there now, it has melted. So the current electricity to your house is stopped, and your implements are not going to be damaged. Whatever damage is there, that will be caused to the fuse wire. Then you can bring another wire and just put it over there. So fuses can be changed.